Hello, so this is my lesson 4.6. I need to get my pen working here. Sorry about this. So this is lesson 4.6. We are solving equations with nth roots and solving radical equations in this lesson. So solving equations with nth roots really is just, we actually have solved these type of equations before. They are actually polynomial equations, but there are a few steps that I've listed here. Step 1 is to isolate the algebraic expression that is being raised to the nth power. Step 2 is to take the nth root of each side of the equation to eliminate the power. And then this third this note here is very important, that if n is an even root, okay, I'm trying to highlight this. If n is an even root, it will have a positive and negative root. So do not forget the plus minus. Going back to my pen here. So then step 3. So step 1, 2, 3, and we'll go through these steps when we're solving these problems. Solve the resulting linear, quadratic, or polynomial equation using techniques that we've previously learned. So when we were first solving polynomial equations, we noticed that if the degree was 5, there were going to be 5 solutions. However, we are not going to be finding all 5 solutions. We are only finding the real solutions, and we are going to round to 2 decimal places if we need to. That will come up once in a while, but not very often. Okay, so this first example, if I look at step 1, it says isolate the algebraic expression that's raised to the nth power. What does that mean? So the x is the part that's being taken to the 5th power, not the 1/2, which means we need to isolate this x to the 5th power. So to do that, we're going to multiply by the reciprocal of 1/2, which is 2/1. And we're going to do that to both sides of the equation. 2/1 is the same as just 2. So you don't have to write 2/1. So the original left side of the equation was 1/2 x to the 5th. The original right side of the equation was 512. So if we multiply by the reciprocal, which is 2/1, now we get a coefficient of 1. X to the 5th equals 1024. So now that the variable and whatever it's being raised to the nth power is by itself, we have to take the nth root of both sides. Well, since the power is 5, we need to take the 5th root of both sides of the equation. So the 5th root eliminates the 5th power. And the 5th, since 1024 is a nice perfect 5th power, when you take the 5th root of 1024, you get 4. Since this is an odd root, there is only one root. Had this been a negative 1024, then your root would be negative. But since it's a positive, your solution or root is positive. So odd roots, I'm just going to make a note here. Odd roots have only one root. So if you are taking an odd root, so if this is an odd number, and you have a positive radicand, you will get a positive root or solution. If you have a root that is odd, and you have a negative number underneath in the radicand, then it will equal a negative solution. So that is something that you want to make sure that you are aware of. Okay, so the next example, example B, we have to look again what's being taken to the 4th power. This whole quantity of x plus 5 is being taken to the 4th power. So we need to isolate that x plus 5 to the 4th power. We've got this minus 4 here. That's an extra term that we do not need on this side. So we're going to add it to both sides. And that will now give us x plus 5 to the 4th power equals 16. So now that we've isolated the expression that's being taken to the fourth power, we need to eliminate the fourth power by taking the fourth root of both sides of the equation. So the fourth root and the fourth power undo each other. So now we have just x plus 5 on the left side of the equation. But be careful here. This is your even root. So when you are taking the even root of both sides of the equation, you will have two solutions, the positive and the negative root of 16, or positive and negative root of 16, which is positive or negative 2. And then when we solve this, you'll hopefully see why both of those will work. So we're looking for something that will make x plus 5 equal positive 2, but we're also looking for something to make x plus 5 equal to negative 2. So at this point, I might suggest that you separate this into two smaller equations. So x plus 5 equals the positive 2, or the x plus 5 equals the negative 2. So if we solve this first equation by subtracting 5 to both sides, we would get x is equal to negative 3. If we solve the second equation by subtracting 5 to both sides, we would get x equals negative 7. So those are actually our two solutions. So if you were to check them back into the original equation, if we were to take negative 3 plus 5 to the fourth power minus 4, would it equal 12? Well, negative 3 plus 5 is 2. If I take that to the fourth power, I get 16 minus 4, which does equal 12. So this is just kind of our check work. And then if we substituted negative 7 in the place of x, so if we took negative 7 plus 5 to the fourth power minus 4, again, it should equal 12. Well, negative 7 plus 5 is negative 2, but when you take negative 2 to the fourth power, you get a positive 16. Minus 4 does equal 12 again. So again, this is our check work, but our solutions are negative 3 and negative 7. Okay, the next problem is one that has a fraction in front of this x minus 3 that's being squared plus 7. So once again, we want to isolate the piece of the equation that's being squared. When you have two things like this to eliminate or undo, you always want to take care of whatever's being added or subtracted first. So undo that part first. So subtract 7. And then now we have the new equation, 1/3 x minus 3 squared equals 3. Now to eliminate the 1/3, again, you would multiply by the reciprocal. The reciprocal of 1/3 is 3. So if we multiply both sides of the equation by 3, we end up now getting our x minus 3 squared equals 9. We then want to eliminate our square. So we're going to take the square root of both sides. Now you can put the 2 in here for the root, but remember it's unnecessary. 2 is the unwritten root, so we don't have to actually write the root of 2, but the square root will eliminate the square, then giving us x minus 3 equals, again, now be careful, you have an even root. So when you have an even root, be careful, watch out. That will be a positive and a negative 3. There will be two solutions, one where x minus 3 equals positive 3, and one where x minus 3 equals negative 3. So we write those two separate equations, solve each one by adding 3 to both sides, and you get x equals 6 as one of your solutions. And then when you add 3 to both sides, you get x equals 0 as your other solution. And then if you check them again back into the original equation, if you put 6 in for x, 6 minus 3 would be positive 3, squared would be 9, 1/3 of that would be 3, plus 7 would equal 10. If we were to put 0 back in the equation for x, 0 minus 3 would be negative 3. But when we square it, we would get a positive 9. Times 1/3 would be 3. Plus 7 would equal 10. So I did just kind of mentally, verbally check both of those solutions, which is always a good idea. Now, in your assignment, problems 1 through 8 are like example 1. The next type of problem that we have is a little bit of a story problem. You are given the equation that you're working with, and you're given a couple pieces of information about it. They're telling you the volume of the cylinder is 1,332 centimeters cubed, and it has a height of 9 centimeters. It wants you to write an equation and find the radius to the nearest hundredth. So they're giving you the formula, so you just kind of have to plug in the values that you know. So V does represent volume, and the volume is 1,332. So if V equals pi r squared h, the 1,332 goes in the place of V. Pi r squared we don't know, but we do know that our height is 9. So if I were to simplify this right side of my equation and put the 9 in front with the pi, I would have 9 pi r squared. Then I, again, want to solve for the radius. That is our goal, is to solve for the radius. So we need to isolate the r squared. To isolate the r squared, we're going to divide both sides by 9 pi. So by dividing by 9 and pi, both 9 and pi get reduced from that right side. Now, this is, for right now, do not put this in the calculator. I will show you how to put this in the calculator. And so this value equals r squared. So to get the r by itself, you will then want to take the square root of both sides. Even though this is an even root, you do not necessarily need to put the positive and the negative, because a radius is a distance and you cannot have a negative distance or radius. So that would not make sense. So in problems like this where your value has to be positive, you do not have to worry about the plus minus. All right, so how are you going to put this in the calculator? We know that r is equal to the square root of 1,332 divided by 9 pi. So when you are putting this in a calculator, again, it depends on what kind of calculator you have, you would need to make sure that the 9 and the pi are in parentheses so that you're dividing by 9 pi and not just dividing by 9 and then multiplying by pi. So anyway, if you put it in the calculator correctly, you should get a value of approximately 6.86. Now, when it comes to the labeling, the radius or the height was in centimeters. Your volume was centimeters cubed. So your radius is a one-dimensional length. So that would also be centimeters. So only the positive answer applies. Only the positive answer applies because the radius cannot be negative. And that goes for any type of a distance. Okay, so that is the story problem. There is one problem on your assignment that is like this. This is number 9. And let me just scroll to it really quick. See if the formula is given. Yes, it is. So you are given the formula. It's the volume of a sphere. So you're going to be putting that 216 in the place of your volume. You will, but there isn't a height this time. It's just 4/3 pi r to the third. So you're, again, going to want to isolate that r to the third and take the third root of both sides. Okay. Going back. Some of you may have a little difficulty taking the fifth root of 1,024. So I forgot I was going to show you how to put that in the calculator. It's hard with a video, but I will do my best. So again, it depends on the type of calculator that you have. So if you have a calculator like we have in the classroom, the TI-30 double X or II or something like that, to put the fifth root of 1024 in the calculator, you have to put the 5 in first, then you have to hit, I believe it's second, and then the caret, so that this X root shows up in your screen. So this would be second and then the arrow up. So you have to hit the second button and the arrow up in order for this to be in your calculator, to show up on your calculator. And then you would substitute the 1024 or type in the 1024, and that will give you your 4. So if you have any questions on how to put in the calculator, please let me know, and I will try to help you with that. All right, so the next type of problems that we have now are radical equations. Our radical equations, in order to be considered a radical equation, the variable must be in the radicand. So the radicand is the part that is inside of the radical. And it has to have an equal sign, and it has to equal something. So I just put equals 5. But again, in order to be an equation, it has to have the equal sign. In order to be a radical equation, the variable has to be in the radicand. When we are solving radical equations, we will also come across extraneous solutions. So an extraneous solution is a solution to the newly created equation, but not the original. So again, an extraneous solution is a solution to the newly created equation, but not the original equation. So we're not going to see that right away, but we will see one of those eventually. So again, I've got some steps here to follow. So step 1, we want to isolate the radical on one side of the equation if necessary. And this is if we have a radical equation with only one radical in the equation. We have other equations where we have 2 radicals in it, but this one has only 1. So looking at this example here, you would want to isolate this cubed root of x plus 5. So you want to get this radical by itself. So once we've gotten that by itself, we're going to raise each side of the equation to the nth power. So we're kind of doing the opposite of what we were doing in the first few examples, and it's going to eliminate the root. And then now we're going to have a new equation. We're going to solve the resulting equation using techniques that we've previously learned, and we must check your solutions for sure when we're doing this. I do have a note here about odd root equations and even root equations. So an odd root equation can equal a positive or a negative number. So, for example, the cubed root of x can equal a positive 7, or the cubed root of x can equal a negative 7. So, with odd equations, you can get a positive or negative solution. When you have an even root equation, it cannot equal a negative number. So there is a difference between an equation that has even power versus an even root. So the equations that we had earlier, we started out with an even power. These were polynomial equations. So when we in order to eliminate the fourth power, we do use the fourth root, but because the original equation is being taken to the fourth power, that's why you can have a positive or negative 2, because you can take positive 2 to the fourth power to get 16, and you could take negative 2 to the fourth power to get 16. Same thing with the square. Well, when you have a square root or a radical equation and you're starting out with a square root, this square root of 2x plus 7 cannot equal a negative number. So there is more to that explanation, but it has to do with the graph and how it only goes to the right. But I don't want to get too far into it. You can ask questions in class if you still would like me to explain it further. Okay, so you cannot equal a negative number. So for example, the square root of x can equal a positive 7, but the square root of x cannot equal negative 7. You might also have an equation. So this 2x plus 7. So the square root of 2x plus 7 cannot equal a negative number. Or if it was a fourth root, let's put something else in there so it's not too much like the other one. So let's say you have a fourth root of 3x minus 1. It cannot equal a negative number. So those are the kind of things you want to watch out for when you are solving radical equations with even roots. All right, so going back to example A now. We want to isolate this cubed root of x plus 5. So you want to eliminate the term that is not part or that's being added or subtracted first. You want to undo any adding and subtracting. So now we have that negative 4 times the cubed root of x plus 5 equals 20. So that negative 4 is being multiplied. So to undo that, we would divide by negative 4. So now you have a cubed root of x plus 5 equals negative 5. So here's where, if this was an even root and it said the fourth root of x plus 5 equals negative 5, I would know that that is not solvable, or there would be no solution to that. But this is an odd root. Odd roots can equal negative numbers. So we are going to continue. So the next step then is to raise both sides of the equation to the third power to eliminate the third root. So now we have our x plus 5 isolated. Negative 5 to the third power is negative 125. Now we subtract 5 to both sides to get the x by itself. So this is now a linear equation. And we get negative 130 as our solution for x. If you substitute the negative 130 back into the original equation to check it, negative 130 plus 5 would be negative 125. The cubed root of negative 125 is negative 5 times negative 4 is a positive 20 minus 6 does equal 14. So verbally, mentally checked that. The next example here, we are going to get two solutions. So we're going to, it's going to be a little bit more interesting. So if you look at your radical, it is already by itself. There is nothing in front of it being multiplied. There's nothing after it being added or subtracted like we did have here. So we can go ahead and start our first step by squaring both sides of the equation. On the left side, you have x minus 4. On the right side, you've got square root of 2x plus 7. Now be very, very careful here. The x minus 4 squared is going to multiply out to be x minus 4 times another x minus 4. So when you have a binomial squared, you are going to get a trinomial. We've talked about this rule, how you can square a binomial and get a trinomial. So that trinomial, the first term comes from taking the x times the x. The middle term comes from taking the x times the negative 4, which is negative 4x, and the negative 4 times x on the inside, which is another negative 4x, which will then combine to give you a negative 8x in the middle. And then your negative 4 times your negative 4 is a positive 16. So the shortcut to squaring a binomial, square the first term. So x squared is x squared. Then multiply the negative 4 times x, which is negative 4x, double it, which gives you negative 8x. Or you can take the negative 4 times 2, give you negative 8 times x, same thing. And then negative 4 squared is the positive 16. On the right side of the equation, the square root and the square simply eliminate each other. And now you got 2x plus 7 on its own. So this new equation now, so your new equation, this is very important, your new equation is quadratic. That is not n. New equation is quadratic. So when you are solving quadratic equations that have an x squared and an x term, you need to move all the terms to one side of the equation and set the equation equal to 0. You also want your x squared term to remain positive if you can. So the x squared term is already positive here where it's at. So I'm going to leave it here. But I am going to subtract, let me change my color here. I am going to subtract 2x to both sides of the equation, and I'm going to subtract 7 to both sides of the equation. Get rid of those, so it doesn't look like you're dividing. So that these terms will eliminate each other, and you get 0 here on the right side. So now our new equation will be x squared minus 10x plus 9. This is a trinomial that can easily be factored into two binomials. This is a basic trinomial, and when you factor these basic trinomials, the x squared factors into x and x. Then you need to find two numbers that will multiply together to equal 9. So that's your C value, but add up to a negative 10 in the middle. That's your B value. So factors of 9 that add up to 10. Well, the only factors of 9 that add up to 10 are 9 and 1. But in order for them to add up to a negative 10, they both have to be negative. So negative 9 plus negative 1 does equal negative 10, but it also has to multiply together. Those two numbers also have to multiply together to equal the positive 9. So that's why negative 9 and negative 1 do work as in your factors. So now that we have it factored into x minus 9 and x minus 1, write your two smaller equations, setting each one equal to 0. Add 9 and we get x equals 9 and x equals 1. So those are your two solutions, but we do need to check them back in the original equation. So I'm going to make this a little bit smaller so we can see the original equation. So if I were to substitute 9 back into the original equation for x, on the left side, 9 minus 4 would be 5. And that would equal, on the right side, 2 times 9 plus 7. So the square root of 2 times 9 is 18 plus 7 equals 25. And the square root of 25 does equal 5. So that checks out. However, when I substitute 1 into the equation for x, 1 minus 4, and then if I substitute 1 in the equation on the right, 2 times 1 plus 7, 2 times 1 is 2 plus 7 is 9, so we have the square root of 9. 1 minus 4 is negative 3. The square root cannot equal a negative answer. So 1 is an extraneous solution, where 9 is the only solution. So this is very different from quadratic equations that we had earlier. Because if you have something that says x squared originally is equal to 9, then x can equal positive or negative 3. So if this is your original equation, then both solutions are okay. However, if it says x equals the square root of 9, and this is your original equation, then x can only equal a positive 3, not a negative 3. I know that does get a little confusing, but again, it has to do with the graph of a radical equation. I'll just kind of put it over here. So your parent square root has a point at 0, 0, 1, 1, 4, 2, and it only goes off to the right. So you only have positive x values. You don't have the negative ones. Okay, this next problem is, again, another story problem, but you are given your equation, so it should not be that difficult. You just have to know where to put what. So pay attention to what the variables represent. So your wind velocity is V. Your air pressure is P. They want you to estimate the air pressure at the center of the hurricane when the sustained wind velocity is 46.2 meters per second. So the wind velocity at whatever pressure, we're going to find the pressure because we're trying to find the air pressure. So you're finding P when the V of P equals 46.2. So you're going to put 46.2 in your equation for V of P. Set that equal to 6.3 times the square root of 1013 minus P. So this is a radical equation. We want to isolate the radical. Since the 6.3 is being multiplied in front, we are going to divide both sides by 6.3. Now, I would hold off on putting that in the calculator. Well, actually, it's not too bad. It's just 7.3 repeating. So when I put that in the calculator, 46.2 divided by 6.3, I get 7.3 repeating, or 7 1/3. But hold that in the calculator. Do not clear it. We want to keep our values as exact as possible. So this is now our new equation. We're going to square both sides of the equation to eliminate the square root. So you can just square that in your calculator. Again, hold that number in your calculator. So now you should have 53.7 repeating in your calculator. And there'll be an 8 at the end because of the rounding, equals 1013 minus P. Now we want to isolate the P. So we're going to subtract the 1013 to both sides. And we now have negative 959.2 repeating equals negative P, but we don't want to know what the negative air pressure is. We want to know what P equals, not negative P. So we're going to, last but not least, divide by -1, which will make that a positive P, and a positive 959.2 repeating. So now going back to the original equation, it does say to estimate. So even though this would round to 595, a better estimation would be 960. So the air pressure is about 960, and then the air pressure is measured in millibars. So millibars, period. I'm just going to keep it at that. All right, so the air pressure is about 960 millibars. Okay. All right, so now we get into the fun ones. We have two radicals. When you have two radicals, it is extremely important that you must have one radical on each side of the equal sign. So in the first example here, both radicals are on the same side of the equal sign. Here's your equals right here. So you cannot have that. So you must move one of these radicals to the other side, or eliminate it from the left side and add it to the right. So the negative radical is the easiest one to eliminate. So if we have a -4th root of x minus 11, we can add a fourth root of x minus 11 to both sides of the equation. So this will eliminate. And now we have a fourth root of 4x minus 7 on the left side of the equation and a fourth root of x minus 11 on the right side. So you must do this. Must have one on each side of the equals. So this is very important. Okay. So now to get rid of the fourth root, we will raise both sides of the equation to the fourth power, which eliminates both radicals very nicely. So this one's going to be a nice easy one. You get 4x minus 7 now equals x minus 11. This is now a linear equation. When you have a linear equation, you want to get the variables on one side and the constants on the other. So I will subtract x to both sides and add 7 to both sides. So the x's eliminate there, the 7's eliminate there. So now I have 3x equals negative 4. Divide by 3 on both sides, and x equals negative 4/3. So you will get maybe some fractions. That's okay. So don't think you did something wrong if you get a fraction. Okay, so technically we should check it back in here just to make sure that we don't get any negative numbers under. Remember, when you have an even root, the radicand, under the number underneath, cannot be negative. So if we were to substitute negative 4/3 in the place of x, would we get a negative number? And actually, we would. So if I substitute the negative 4/3 in the place of x, just double checking to make sure. Yeah. So I would get a negative 16/3 minus 7, which would be a negative number. So you cannot have a negative number underneath an even, inside of the radicand of an even root. So negative 1/4 actually is an extraneous root. So what if that's the only possible solution and it's an extraneous? So when that happens, your answer then is simply no solution. So that's what you need to write if the only solution you're given, or the only solution you find, makes this negative underneath, or would make the square root equal to or an even root equal to a negative number. Okay. This next example here is a long one. So if you need to take a break, do it right now. Come back to it, because this is going to take some time. We do have two radicals again, but when we square both sides, we have this extra +1 here. So when you are squaring the left side of the equation, you are squaring a binomial. The square root of x plus 6 is like your a, or your first term. The 1 is your second term. So again, using that special product rule, it's very helpful if you know those special product rules. I'm just going to write it. Let me put it up here at the top of the page. So a plus b squared equals a squared plus 2ab plus b squared. So when you have a binomial squared, you get a trinomial. So the first term squared will be the first term in your product. The middle term, you would take the a and the b, or double, take 2 times b and then times a. It doesn't really matter what order you multiply in. And then the third term, b squared, is the second term squared. Okay, so now we have this square root of 6, x plus 6. So if I, again, a squared plus 2ab plus b squared is my formula. So a is being represented by this square root. So if I take the square root of x plus 6 and square it, then 2 times a, which again is the square root of x plus 6. But then you have to multiply that times b as well. So that's 1. And then plus b squared. So 1 squared. So that's our a squared, 2ab, and b squared. So when we simplify that now, the square and the square root go away. And you now have x plus 6 plus, now here the 2 and the 1, you can multiply those together. So that's why I was saying earlier, if your b value is something other than 1, take your b and double it, then multiply it by the square root. So 1 times 2 is 2, and then square root of x plus 6. 1 squared is just 1. But remember, this is only the left side of the equation. We haven't even dealt with the right side of the equation yet. Well, the right side of the equation has another square root. Square root of x minus 7. It does not, however, have an extra term like this plus 1 over here. So the square root and the square do eliminate each other. So we just have 7 minus x on this side. All right, so getting to this point is half the work. But now we want to isolate the radical again, because now we're down to one radical. We only have one radical in the equation, or one square root in the equation. So we have to isolate this radical. So most of these problems work out pretty nicely where it's not going to be too difficult. Things are going to cancel out sometimes. But this x here, if I eliminate it from this side, because remember, I'm trying to get this radical by itself. So I'm going to subtract x to both sides of the equation so that this goes away. Now I could combine the 6 and the 1 first in one step and then subtract, but it really doesn't matter. I can subtract 6 to both sides of the equation, then subtract 1 to both sides of the equation. Either way, the 6 goes away, and the 1s go away. So at this point now, we still have this 2 in front of the radical. But the 7 minus 6 minus 1, it becomes 0, so that kind of goes away. This negative x minus x, though, does not. If you had a negative x plus x, then you would have a 0 over here. But if you have two negative x's or two positive x's, then you will have either negative 2x or positive 2x. At this point now, we do want to eliminate this 2 that's being multiplied in front, so we would divide both sides by 2. So now, again, we have this radical by itself. The negative 2 divided by 2 is negative 1x. At this point, we would then square, now that we have the radical isolated, you're going to want to square both sides of the equation. So that eliminates the square root. And you get x plus 6 then equals, now this is the other nice thing that happens here. When you square this negative 1, it becomes positive 1, so you don't even need to write that. But you do need to square the x also, so you get x squared. Now, had there been a number in front here, like a 3, then you would have to square 3 and get 9, so be careful of that. So this is looking a lot easier now. We do have an x squared term and an x term, though, which means this is a quadratic equation, which means we need to set the equation equal to 0, and you want to maintain that x squared being positive. So I'm going to subtract x and subtract 6, so that I'm going to get 0 then on the left side. Now we factor this. X, two numbers that multiply together to equal 6, but have a difference of 1, 3, and 2. The signs are going to be different. The larger one's going to be negative, so negative 3, positive 2. And then if we set each of those equations equal to 0, we would get 3 as one possible solution and negative 2 as the other possible solution. So we do have to check them back in the original equation. So I'm going to rewrite the original equation down here. I know there's only a couple of these problems, but they are kind of fun. My idea of fun, anyway. All right, so this was the original equation. So if I were to substitute 3 in the place of x, I would have to do that to both sides of the equation and then simplify. So 6 plus 3 is 9. The square root of 9 is 3 plus 1 does equal 4. On the right side, if I take 7 minus 3, I get 4, but the square root of 4 does not equal 4. It equals 2. So negative or positive 3 is not a solution. It does not work when you put it back into the original equation. So now we have to check the second solution, which was negative 2. And there are possibilities where neither answer does work, but if that does happen, I would definitely go back and check your solutions again. All right, so again, this is my original equation. If I were to substitute negative 2 in the place of x, I would have negative 2 plus 6 in the radicand plus 1 equals, and then again substitute negative 2 in the place of x. But be careful, this is 7 minus x, so it's 7 minus a negative 2, which will make that a positive 2, and which will equal 9. So you now have square root of 9 over here. Negative 2 plus 6 will be 4. The square root of 4 is 2 plus 1 does equal 3. So your solution of negative 2 does work in this problem. Okay, couple more examples, and then we are finished with this lesson. This is a 2-day lesson. All right, so example 4 here. We have rational exponents. So just like radicals, when you have a radical, you want to isolate the radical. Well, you want to isolate whatever is being taken to that power. So we want to, since the 3x is in parentheses, you need to isolate this whole thing. So get rid of the 2 by adding it to both sides. And now we have 3x. Again, that 3x is in parentheses to the 3/4 power equals 27. Now, in this case, we want to multiply, or not, we want to raise both sides of the equation. Raise to the power of the reciprocal of the exponent. So one thing that you should know is with fractions, if you multiply a fraction by its reciprocal, it equals 1. And if you raise an exponent to another exponent, so if you raise both sides of the equation, if you have an exponent outside of an exponent, or you're raising a power to a power, those exponents do get multiplied. Now you do need to take both sides of the equation to that power. So on the left side, the exponent, the power to the power, will give us an exponent of 1. So if you take 3x to the first power, that's just going to be 3x. Now your 27 to the 4/3 power, if you can, try to do this mentally. The 3 is the root, the 4 is the power. So you can rewrite this as a cubed root of 27 to the 4th power. Well, the cubed root of 27 is 3. 3 to the 4th power is 81. So that one worked out really nicely, gave us a nice whole number. So then our last step then is to divide by 3, and we get our solution of 27. Again, you can substitute the 27 back into the original equation. It does work, but for time's sake, I am going to move on. This is our last example. we want to isolate the quantity x minus 2 to the 1/2 power. So look at what is being raised to a power. We want to isolate this piece. So that 3 is a problem. But we also have a variable on the other side. So that's a problem as well. So if we were to divide both sides by 3, we would now have a fraction over here. So I don't know about you, but I don't really like working with fractions a whole lot. So we sometimes cannot isolate this this quantity that's being raised to a rational exponent. So in this case, we would raise the whole side of the equation to the power of the reciprocal of that 1/2. Well, the reciprocal of 1/2 is 2, or 2 over 1. On the right side of the equation, you originally had x, but that right side of the equation also needs to be raised to the second power. So we're basically taking both sides of this equation. So this and this are the same. This and this are the same. So we're raising both sides of the equation to the second power, which keeps it equivalent. But this left side is a little bit tricky because this 3 is being multiplied in front. So you must square the 3 and square the quantity x minus 2 to the 1/2 power. So when you square the 3, you will get 9. When you square the quantity x minus 2 to the 1/2 power, the 1/2 and the 2 multiplied together do equal 1. So you do end up getting 9 parentheses x minus 2 to the first power, or just x minus 2. On the right side, though, we don't have a square root. So when we square the x, we get x squared. Now, on the left side, we do have a little bit more simplifying to do. We can now distribute the 9 into the parentheses, and we get a nice quadratic equation. So again, with a quadratic equation, you want to get the equation equal to 0, and you want your x squared term to be positive if possible. So I'm going to leave the x squared on the right. I'm going to subtract 9x and add 18. So that those terms are eliminated from the left side, and I now have 0 equals x squared minus 9x plus 18. We now need to factor this, which this will factor into x minus 3 and x minus 6. So if we set each factor equal to 0, we will get 2 possible solutions of 3 and 6. So again, you need to double check this back into the original equation. So your original equation is right here. So this is my check work. So if I take 3 times 3 minus 2 to the 1/2 power, does it equal 3? So we are substituting the 3 in for x here and there. So 3 minus 2 does equal 1. 1 to the 1/2 power, or 1 to any power, is 1, times 3 does equal 3. So 3 is one solution. Now we have to check the second solution. So again, this is check work. So again, we got 3 parentheses x minus 2 to the 1/2 power equals x. But in place of x this time, we are going to replace with 6. So simplify the parentheses. 6 minus 2 is 4. 4 to the 1/2 power is 2, because 1/2 power is a square root. And 3 times 2 does equal 6. So both are solutions. Both are solutions to the equation. All right, so that concludes our notes over solving radical equations.